Today we will be doing the expressions and equations chapter, which will deal with equivalent expressions, and at the end we'll talk about combining like terms, which will continue tomorrow also. So what are equivalent expressions? They are the same expression, but they look different. What this means is you are able to change an equation to look completely different than before using three properties, but in the end they will have the same value. So those three properties are distributive, associative, and communitive. Distributive and associative both have multiplication and addition properties inside them. They both have formulas. So we'll go ahead and look at distributive first, which is probably the most difficult out of the three. Distributive is also called factoring, so if I ever refer to it as factoring, I'm talking about the distributive property. The addition starts out is A in parentheses B plus C equals AB plus AC. Now for that, you want to be able to put it into the end factor. So you would take A and multiply it by both of the factors inside the parentheses. So it would be A times B plus A times C. And the reason that it's addition at the end is because it was addition inside the parentheses. Now to reverse this and go to addition, AB plus AC, you need to take out the common factor in them both. The common factor in AB plus AC is A. So to take out A, that would leave you with B plus C inside the parentheses. We'll go ahead and look at some examples to clarify things a bit. All right, we'll start with 2 in parentheses x plus y. So the first thing you're going to do is take 2 times x, which would give you 2x, and 2 times y, which would give you 2y. And the sign would be addition because it is addition inside the parentheses. So your end result would end up being 2x plus 2y. Now here's another problem, 4 and in parentheses 2x plus 3y. Can anybody tell me what you need to do first? Kim?
Multiply 4 and 2x.
Good. So 4 times 2x is
8x.
okay, and then 4 times 3y would equal, and that end result would leave you with 8x plus 12y. And like I said, it is addition because it is addition inside the parentheses at the beginning. All right, and here's one more example, and then we'll move on. 3 times x squared minus y. So again, you start out multiplying 3 times x squared, which would give you 3x squared, and then you would multiply 3 times y. Now, can anybody tell me what the full end result would be?
3x squared minus 3y.
And that would be as a result of having the subtraction in the parentheses at the beginning. Does anybody have any questions? Okay, we'll go ahead and move on. Now this is just a cute thing I thought you'd like. As you can see, the bird outside multiplies against the pig, and then the bird outside again multiplies with the pig with the hat, and it's addition because the addition inside the parentheses. Alright, and this is the addition side. We have 3x plus 3y. You always need to ask yourself, what do they have in common? What is the common factor in this equation? Now, in this specific equation, it's 3. That is the only thing that they have in common. So you take 3 out and you put the remaining into a parenthesis. So the answer would be 3 times x plus y. 4x plus 8y. Now this is a little trickier. Can anybody tell me what this equation, each factor, has in common? Right, because 4 goes into 8 2 times. So if you were to take 4 out, that would leave you with 4 times x plus 2y. Anybody have any questions about why that's 2y? Okay, and then the last one, it's a little trickier. You always remember that you can take out variables just as well as you can take out coefficients. So what is the coefficient that is in common here? 3, right. So, and there is also an x in both. So you are able to take out 3x instead of just a number. So that will leave you with 3x times 2x plus 3. The associative property is also called grouping. You can group these together any way you feel fit, and they'll still come out as the same value. It will still be equivalent, and it goes for addition and multiplication, but I will show you examples of both. So like I said, you can regroup anything and they always come out to be equivalent because the order does not matter. So here I'm going to prove to you why these two equations are the same. They have the same numbers, but they're grouped differently. Now here you have to remember the order of operations. Parentheses go first. So on the left-hand side, 3 plus 4 is 7, and then you add 2 plus 7, which is equal to, good. And then on the right-hand side, 2 plus 3 equals 5, and then 5 plus 4 equals, right. So in the end, these have the same value because they have the same numbers, and it's all addition. So in the end, it's part of the associative property. Now you can also, if it comes up like this, if it helps for you, you can group them any way you want. You could group them 12 plus 2, or 12 plus 5, or 2 plus 5. I personally chose 2 plus 5, so we'll solve it that way. So 2 plus 5 is 7, and then you add that to 12, and you get 19 for an answer. Does anybody have any questions? The multiplication rule works the exact same way, and again, parentheses first as the order of operations. So 3 times 4 is, good. And then you take that times 2, good. And it's the same over here. 3 times 2 is 6. Take that times 4, and that brings you to 24. Overall, the same equation, just in different orders. So 9 times 6 times 9, group it any way you'd like. 6 times 9 is, right, and can anybody do the math for me? Tell me what 9 times 54 is?
486.
Perfect, that's great. Good job, Kim. Alright, and then we have this one. This has a variable in it. So you can multiply just how it is using the distributive, or you can break it up and make it 2 times 3, do that in parentheses, and then 6 times x. And that will give you 6x as an answer. Now, if nobody has any questions, I'll move on to the commutative property. Now, commutative property, you do not simplify. You only move things around. You can only just group them, not group them, but you just rearrange them differently. If I were to give you a worksheet, the commutative property equation would be the one with no answer at the end. It would be the one that was only moved around a little bit. So there can be multiple answers as you can move them around differently than your friends. So don't panic if you have different answers. It doesn't mean it's necessarily wrong. So 59 plus 12 is going to be the same answer as 12 plus 59. 14 times 102 will be the same as 102 times 14. And here's an example of multiple answers. 14 times 12 times 21 can be the same as 12 times 14 times 21, or your next door neighbor or your friend would have 21 times 14 times 12, which is perfectly correct as well. Now, combining like terms, it's a little hard to get your mind wrapped around it. Variable value is what we're going to talk about. Variables are the letters that represent a number that you don't know. So x is the same as x, but x squared is not the same as x. X squareds only combine with other x squareds. They have to have the same variable value. So for the first example, 3x plus 5x minus 2x. They all have the same variable value because they all have one x, which means you can combine them all. And when you combine them all, you only combine the coefficient in front. So it would be 3 plus 5 minus 2. So 3 plus 5 is 8, minus 2 is 6. So the answer would be 6x, because you were able to combine them with the like terms. Now with the second example, they are not all like terms, because we have an x, we have a number that doesn't even have an x, we have another x, and then we have an x squared. So there's only two factors in that equation that can be combined. Can anybody tell me which factors those are?
7x and 89x.
Right. So your final answer would be 86x plus 7 minus 52x squared. Now is the third equation a like term equation?
No.
Why not?
Because none of the variables are the same.
Right, so that is your answer right there. You cannot combine anything. And the last one, are they all the same variable?
Yes.
Okay, so you can combine all of them. So 98 minus 52 plus 130. Anybody want to do the math for me? Kim.
176x squared.
That is perfect. Great job. Does anybody have any questions? We're going to work on some more examples. Okay, so don't forget, coefficients only are the only thing that combine. Never combine the actual subscripts on the variables. So 4x plus 5x, you always ask yourself, are they the same variable value? And they are, so it equals 9x. 12x squared plus 12x squared, do they have the same variables? Okay, so they equal 24x squared. 15x plus 22x plus 2x squared equals 37x plus 2x squared, because they don't all equal the same thing, but there are two that equal each other. So you add those two together and you leave the 2x squared alone. So 15 plus 22 equals 37x. And then you cannot forget the 2x squared. So here's examples for you to work out. So get a pen and paper out and work on these. 9x plus 15x plus 2x. Do they all have the same terms? Yes. So you go ahead and add those together. Can anybody tell me what those are?
26x.
Really good. Okay. And then a second example. 4x to the fourth plus x to the fourth plus 2x to the fourth. Do they have the same like terms?
Yes.
Then you can add them all together. What would that give you?
7x to the fourth.
Perfect. 3x squared plus 2x squared plus 49x plus 9 plus 7. They don't have the same variable all across the board. So tell me what can be combined.
3x squared and 2x squared, 9 and 7.
Okay, so can somebody else give me the answer?
5x squared plus 49x plus 16.
Perfect. All right, and this last one, it's a little tricky, and I'll give you a hint. Obviously, as you can see, they do not all have the same exact variable. So what you're going to do is rearrange them. Use the commutative property and rearrange them so you can see them better. So you're going to go ahead and put all the squareds together, all the variables that have the one value, and all the single digits. Put them all together, group them, and then add them that way so that you can have an easier view. Now, can any brave soul give me the answers to this?
50x squared plus 41x plus 6.
That was great. I'm definitely going to give you some extra credit at the end. And that will be all for the day, and I'll hand out your homework in just a little bit.